All right, today we're going to look at linear inequalities and absolute value inequalities. And again, this is review. So the first one, we're going to solve negative 1/2 x less than or equal to negative 5/4 plus 2/5 x. So as you see, I have fractions, and just like with equations involving fractions, I can do fraction busters with inequalities. So I take a look at the denominators, a 5, a 4, a 2, so I can see that 20 is going to be my least common denominator. That's what I'm going to multiply by. Now, because it's a positive 20 that I'm multiplying by, I don't have to worry about the inequality changing. So 2 goes into 20 10 times, so we have negative 10x. And here we have 4 goes into 25 times, so I have negative 25. 5 goes into 24 times the 2 is 8, so we get 8x. So I'm trying to get the x by itself. I'm going to subtract 8x from both sides, and we get negative 18x less than or equal to negative 25. Divide each side by negative 18, we get x. Now be careful here because I'm dividing by a negative, so that switches this to greater than or equal to 25/18. So remember, to flip inequality, when multiplying or dividing by a negative. Okay, now how are you going to write your answer? There's a few different ways I want you to think about this. One is to put it on a number line. Now when you do the number line, you don't have to actually number a whole bunch on there. Hopefully you recognize that this is larger than 1 because it's bigger than 18/18, but it's less than 2. So, but I'm just going to pick a spot. I'm going to call that 25/18, and I want the numbers where it's larger or equal to. So because of the equal to part, we fill it in a circle to represent that it could be equal to that. And then I'm going to shade the number line, and I'm not doing a very good job of that, to the right to show that it's the numbers that are larger. So doing it with a graph is great. The other way I want you to be able to do is with interval notation. So you need a left bound and a right bound. Well, I can see I have a left bound of 25/18, and it includes the 25/18, so we use a bracket. And then I put a parenthesis, and now I need my right bound. Well, there is no right bound, so I need to show that the right bound is actually infinity, and I put a parenthesis on that side because you can never include infinity, so it's always going to be a parenthesis if you are using that. If you're using infinity or negative infinity, it will be with a parenthesis. Okay, example 2. Another fraction problem. I'm picking these because I know those are ones that you need more practice with. So I'm going to do fraction busters. And here I'm going to multiply by a 15 when I see the common denominator. So 3 goes into 15 5 times. So I'm going to have 5 times the quantity x minus 1. 5 goes into 15 3 times. So I have 3 times the quantity x plus 2. And 5 goes into 15 3 times, so I'm going to have 3 times 3, which is 9. So I'm going to distribute. And then combine like terms. So we have 8x plus 1 less than or equal to 9. Subtract 1. So I get x is less than or equal to 1. Now, before I do interval notation, I actually think it's easier if you do a graph first. So here's the 1. Again, I have equal or equal to, so we're going to fill it in. And this time I want the numbers that are less than, so I'm going to shade to the left. So remember, we need a left bound and a right bound when we put it in interval notation. Well, notice that I don't have a left bound. It keeps getting smaller. So that means my left bound, I'm going to put negative infinity. And on the right, I'm bound by 1, so I'm going to put a 1, and since it includes the 1, it gets a bracket. So this is interval notation, and you definitely need to know how to write your solution set in interval notation. Keep in mind what this means. Every number that is less than or equal to 1 is a solution to this inequality. So remember, that means there's infinite solutions. Every number within this range is going to be a solution. All right, the next type is solving compound inequalities. So when you have a compound inequality, it's actually just two different inequalities combined together with the word or and the and ones can sometimes be a little confusing because they might not actually use the word and. So here we just treat these two as two independent problems and we work them out. So I'm going to subtract 3 from each side and then divide by 2. Didn't do anything with a negative, so I don't have to flip. And or is actually part of my answer. I'm going to add 1 and divide by 2. I'm sorry, divide by 5. The answer is 2. So here's my answer. X is less than or equal to 1/2, or X is greater than or equal to 2. So on a number line, what that looks like. Oops, I have a problem right here. I'm so glad I caught that before you all told me tomorrow. No equal to part there. So I'm going to plot the 1/2, which obviously is going to be to the left of where the 2 goes. So I want the numbers that are strictly less than 1/2. So this time it's going to be an open circle, since I don't want to include 1/2. Or the numbers that are 2 or greater, so I'm going to fill this in and shade to the right. Now, interval notation. Unfortunately, you can't combine this into one little notation. You're going to have two things there. So for this first part, we're bound on the left by negative infinity, so we're not really bound. Bound on the right by 1/2, not including the 1/2, so we put the parenthesis. And then instead of the word or, I'm going to use this symbol right here, which means union. And actually, it's the same as or. So we're going to use this union symbol. And on this right part, we're bound by a 2, including the 2. It gets a bracket, and it continues to get larger. So we put the positive infinity on the right. Notice that in your notations, you'll never have a negative infinity on the right. It's always going to be on the left if you're having that as one of the values, and you'll never have a positive infinity on the left. So you want to always make sure that you check for that. If there's a negative infinity, it's going to be on the left. If there's a positive infinity, it's always going to be on the right. Now, this is a compound inequality, and remember I said there would be an and or an or. This one, you can't really see it, but it's there. What this says is 3y is less than or equal to 4 minus 5y, and 4 minus 5y is less than 5 plus 3y. So this time we have an and, so you'll just separate that and then solve both parts. So here I'm going to add 5y and divide by 8. And over here I'm going to, I think I will, I'm going to subtract 3y. And I'm going to subtract 4. So I get negative 8y is less than 1. So we have y is greater than, because it flips when you divide by a negative, negative 1/8. And we have an and. So when we graph this, I'm going to plot my negative 1/8 and my 1/2, which is obviously to the right since it's positive. So I'm not including the negative 1/8. I am including the 1/2. I want to be larger than the negative 1/8, so that's to the right. Oops. And okay, I know you're laughing at me right now. I can handle it. Let's see if I can get it right this time. So I'm going to be to the right of the negative 1/8 and to the left of the 1/2. So here's my solution set. Now when you put this in interval notation, notice I am bound on the left by negative 1/8, even though it's not including the negative 1/8. And I'm bound on the right by 1/2, including the 1/2. So this is what you write for interval notation. Okay, next thing is solving absolute value inequalities. So first I want to just kind of remind you of how you can think about this. So when you see the absolute value of x minus 4 is less than 3, think of that as the distance between a number, x, and 4 is less than 3. So here's my number 4. And I need to go, I don't know what that number is. I don't know which direction I'm supposed to go. All I know is that it could be a distance of 3 this way, or it could be a distance of 3 this way. So here that would put me at 7. Here that would put me at 1. So clearly I can already see my solution since I'm not including it has to be less than 3, not less than or equal to. So this has to be my solution. But how do we do that algebraically? Well, remember we would do 2 cases. So you isolate the absolute value, which it already is here. So we have x minus 4 is less than 3. And for the second case, we're going to have x minus 4. We're going to switch it to greater than and make this the opposite. And that would just indicate going the opposite direction. So remember that we need to connect this with either an and or an or. So remember greater, and if you remember that, that will help you remember that greater is for the or. Well, this is less than, not greater. So this is going to be an and. Okay, and you can kind of tell anyway because you're within those 2 values. It's greater than 1 and less than 7, so that should make sense to you as well. So then when we add 4, we get x is less than 7 and x is greater than 1. Okay, so remember absolute value inequalities, 2 cases. The second case, you flip the inequality, change it to the opposite, which indicates the opposite direction. So on a problem like this, right away I'm just going to look and see this is greater, so I know this is going to be an or problem. You do have to isolate the absolute value first before you break it into your 2 cases. So now I have 2x plus 1 is greater than or equal to 8. Remember we already decided that it's an or. 2x plus 1 is less than or equal to, and we make that the opposite. So then you just go ahead and solve. So we get x is greater than or equal to 7/2. Over here, we get x is less than or equal to negative 9/2. Make our number line. The negative 9/2 clearly is smaller than positive 7/2. Both of them are going to be filled in circles because of the equal to parts. And I need to be less than the negative 9/2 or greater than the positive 7/2, which means for interval notation, you're going to have to do 2 symbols or 2 expressions here. So we have negative infinity to negative 9/2 bracket, union, bracket, 7/2 to infinity. That's interval notation. Okay, and the last thing I think we're asked here to do is to describe, okay, hold on for a minute. I don't know what just happened. Okay, describe all the x values within or including a distance of 5 units from the number 7. So this time we're basically being asked to write an absolute value expression. And we need within or including a distance of 5 units from the number 7. So let's think about it first. So I'm measuring from the number 7, and I need to be either 5 units this way or 5 units this way. And so we're looking at some distance that some number is from 7. So we did an example kind of the other direction on this. So my expression for this would just be some number, the distance between x and 7, has to be within or including, so that would mean less than or equal to 5. And that's how you could describe it, with that absolute value inequality. Okay, so that was it.